mostly, is what an attacker's after. So as you're looking at what makes the most sense and where do you need to start, as you're looking at segmenting, you need to pick the places that's going to have the highest return on investment and meets the criteria of your company. So as we look at a couple of those different places, we've got up here, basically your user network, your external WAN. You've got your data center here. And so one of the places you can put it is you can put physical firewalls between those two. That's a good place to segment kind of at the data center edge. A lot of people will start there because it can be low impact. And that solves the need for, okay, now I'm looking at user traffic going into my data center. So if I take the methodology of a zero trust network, so to speak, that's a good starting point. And a zero trust networking was one of the concepts that Forrester came out. So there's a bunch of literature from Forrester that you can actually go up, so it's industry validated, kind of what the goal is. Or if you're gonna make it similar to like an airport security, that's one of the goals of airport security, is to be able to always inspect who someone is, authenticate who they are, authenticate what they're doing at all points in the process. We know that doesn't always work great for airport security, as many people have proven they can sneak through it. But that's kind of the goal. As you continue on then closer, so you've got all of the different, if you only put it there, you've got all these other places where the data actually sits. So if your goal is to keep on moving it closer and closer to where that data actually sits, you can put boxes here to protect the physical boxes. You can have virtualized systems. So this is if you're using like ESXi, vCenter, KVM, Hyper-V type systems. You can have it there, and we'll talk about that. And then finally, you can move to something like NSX, and we'll talk about where that's at. The other thing that we've seen is as data is moving around, this used to be good enough that you could just put stuff here. But we've now seen traffic move up to the cloud. So we've now got workloads and data in the cloud. And as security people, we basically want to say, no, you can't do it because it's risky, is what a lot of us want to say. Unfortunately, that's not a realistic from what a lot of the executives are saying, is they want operational flexibility. And one of the ways you can get that is by using that on-demand stuff that you have up in the cloud. So as we fill it out, I'll fill out the slide deck. So you've got the hardware firewalls. As you look at the various different places that you can have virtual firewalls, this is where I think in the future a lot more of the segmentation that we're doing is going to sit here, because it's a lot easier to put it closer to the actual traffic. From the importance of, we can all get into this too, having an API or the flexibility of being able to control stuff. So your change control is more managed, as well as what you've got going in and out. You can have the firewall do things and automate a lot of the processes is an important aspect. Management of all that, and then from an orchestration standpoint, this is where the API pieces come in. So you've got all these different technologies. We're moving down the road for software-defined networks. Security has to be a piece of that. That is our goal from a segmentation perspective, is security needs to be a piece of that. So you've got all these different orchestration techniques that you need to use. And that includes things like ACI. So most of these other solutions, like all of this stuff down here and all of these stuff here, focus on the application and extending security from the application down into the network. Cisco, with their ACI, has kind of switched that on its head, and they want to use the network as the center point and extend then stuff to the application. So we'll talk about some of the pros and cons of that, and how that works and how that's different now that ACI is becoming more and more important, or at least Cisco's talking a lot about it. So when we look at what segmentation is and what segmentation is not. When you think of segmentation, a lot of people think that, okay, I can put ACLs there, or I can have an ASA that I drop in, and that I can create my policies. I've got my layer 4 policies that I can use to basically control the traffic. That's not good enough, and the reason that's not good enough is that that's really hard to read. As you look at some of the various different applications that you've got, if you look at the ports that these use, a lot of people are starting to use Microsoft Link as a phone system. To use Microsoft Link, you basically have to open up every port, because that's what it's designed to use. So it's really hard to segment your traffic when you have to allow all of the ports to go on if you're using the Microsoft Link application. So the applications that are running on the network are what's driving what the decisions have to be made. If you look at other stuff, you look at Oracle. So we've got a database there, it uses 1521. But we've got some other Oracle applications that are using all other kinds of ports. So as you're opening up ports, that's the reason that ACLs are no longer good enough to actually be able to segment stuff. Or if you look at other applications like iSCSI, you're able to identify what the actual traffic is. So I pulled this off of the post-mortem from the hacking team incident, because you would have thought the company's goal is to do nothing but hack other people. They should have pretty good security. Well, if that's the case, why was the person who got in here able to use iSCSI, initiate iSCSI stuff from the outside, and that's what he used to be able to access all their stuff internally? So there's work that can be done even for the experts. And so I didn't want to use the target breach because everyone knows about target, and I want to use someone who's supposed to be good. So when you look at the context of traffic and what that context actually means, this is what we typically, to continue on with like the ACL or the ACLs, this is what we typically make a decision with on the traffic, is you've got this. Who on your guys' network, if you got a flow like this, is this a yes or no flow? Would you allow this or would you deny this traffic on your network? Depends what the endpoints are. Okay, good point. What is the traffic? Can you tell by that? What's that traffic? RDP.
You think it's that?
Yeah, exactly. You think it's that. So you're gonna, most people, if they've got a server administrator or they've got somebody who's a server user, they're gonna open up RDP to their server network. So if we expand some of what that means, we can tell some other things about traffic. Okay, IP addresses. We know that it's in the US because of the internal IP address. If we look at the actual, let's look at the category. We know that it's a private IP address. What if we now know who's the user here? So the user here is S. Jacobson. Is this type of information starting to make more of a difference in whether or not you allow that traffic flow? Yeah? We now know the AD group, so they're part of the development group. So we know, even though we thought it was 3389, it's SSL. Could that still be remote desktop? Possibly, yeah. Possibly could. So if we decrypt that traffic, we now know that the protocol is not the RDP protocol though. It's this RFB protocol. Okay, so what does that mean? So we break it down and it's actually VNC. So somebody is running VNC over 3389. And you look even further and you now see that it's a file transfer. So they're running VNC over 3389, doing a transfer, and that's the file that they're transferring. So has the context that you've had from a security standpoint made a difference when you have this type of information versus just the initial ACLs?
But only if you don't know anything about the destination server. If it's your server and your change control, you better know what's running on it. If it's a Linux box running 3389, then you got a problem.
Right.
But if you don't know what the server is, then you're stupid for it anyway.
Good point. Good point. So if you take another example of this, you've got the SEP service. So now we've got Symantec service has been compromised, and it's actually using SMB to send files to the SharePoint server. Okay, does that make sense? Because from an SMB standpoint, no, it probably doesn't make sense. Does the SEP service probably have access to be able to send files to the SharePoint server? Yes, because it's running some endpoint version or some endpoint virus. But should it be downloading executables? No. So as you've got information like this, being able to make policy-based decisions based on that information is why it's important to look at segmentation and not just ACLs. So then looking at the actual traffic and some of the ways that we segment it. So from a physical standpoint, there's a couple of different ways that we can break this down. One of the ways is via a layer 3 mode. So if we look at the traditional traffic in the layer 3 mode, we're going to be sitting as that kind of layer 3 core. So the traditional traffic mode is you've got some kind of workload down here in VLAN 6. That workload is going to go up, and it'll go back down here and talk to VLAN 5. That's a typical type of path, because these 7Ks or whatever they are is handling core routing. Correct? I guess I need to fill out a slide there. So yeah, there's the initial traffic flow. So the way you would use kind of a layer 3 type of mode is you make the firewall part of that core router. There's pros and cons to that, we'll get to that. But if you do make that, you're going to end up swinging the SVI for that VLAN 6 over onto the firewall, and you also create a transport VLAN back to the actual port. So as traffic comes through now, the traffic is going to look like this. So this is how we're pivoting the traffic and actually implementing the segmentation. So traffic now has to go to the firewall and be analyzed by the firewall to go back to the next VLAN. You also notice though, because of the way VLANs work, and it's layer 3 by default, if it was traffic in VLAN 6 and it's going to traffic in another server in VLAN 6, it's never going to reach there because it's going to hit this port and it's going to come back if it's not on the same host. So we're very much still limited by segmenting based on VLANs only. So that's one of the reasons that people have started to try and get rid of big, massive server lakes that they've got and try and move to more segmented VLANs of the traffic they're looking at. And then the same thing would apply then as you start to move other VLANs. So initially if you had VLAN 4 and 5, the same traffic flow would be happening there. But as you swing those VLANs over, more and more VLANs get to be segmented by the firewall. You're able to inspect all that traffic, apply all those policies. And so it makes kind of a cutover period. The question is, how fast does that cutover period happen? If you're building it from the ground up, something like this works well. If you already have routing protocols and other types of decisions in place, something like this could be more difficult to do because the networking team often doesn't want to make changes to what they have from their core routing. Really? Yeah. So, what's that? You the networking guy?
Yeah, we know that networking guy.
I think I know your networking guy. Dan? No? All right. So some of the pros here is it's a good way to be able to quickly move a lot of VLANs and be able to segment a lot of VLANs. But you can, as you're swinging those, you have to swing the entire VLAN all at once. So if you've got a whole bunch of different traffic in that VLAN, a lot of times there's nervousness because now you have to figure out exactly what that traffic is going to look like if you're writing policies as you swing it. So a lot of times if you are doing that, people write any rules to just inspect the traffic, gain visibility of the traffic so they know what's going on. Some of the downsides, the other pro that if you are going to do this, the other pro versus some of the other processes is this is actually keeps your natural routing troubleshooting process. So when people think of traffic, they think of it goes from this router to this router to this router. And so if something happens in between, they say, okay, where is my next hop? And they can see what that next hop is in the traditional traffic flow. So that's kind of one of the pros to this if you actually are going to sit there. The cons is that you are changing your SVIs. So it's impacting routing. If you're using IHERP, a lot of people aren't going to support that. Some people will. If you're using other protocols, there's other ways that you have to do that, balance that, set up load balancing, a lot more HA failover, things like that. So it can be a little more complicated from that side. It's transparent insertion. So to kind of give it another view, or to try and put this in a different way. So this would be what a typical scenario would look like. Is you could have a database VLAN. That traffic goes through the database's zones, is what we call them. They go down to the virtual router, they go to your ERP zone, and they're accessing the traffic down the Mount VLAN. So as you're segmenting stuff, that's kind of the flow that you're flowing through now. And you've got various different places that you can put those. So as you're blocking stuff, you can write policies at those various different zones to be able to stop stuff. Or here's another one. So you've got, even if they're on the same data center switch, you're still forcing the traffic to come through the different VLANs from the backup to the infrastructure VLANs. So it's a way that you can still apply policy through those. Another mode that you can do is what we call layer 2 mode, or bridging mode, is something that you can use. And so this is going to be very much the same thing as a layer 3 mode, except for we're not sitting with the SVIs. What you're doing instead is you are taking that traffic, and so this is going to be VLAN 6 here. We're actually going to start changing those VLAN tags or those tags inside of VMware or whatever it is, and change those to VLAN 106. As we change those, we now have in the firewall the fact that we've got this bridge that's going from VLAN 6 to VLAN 106. And so the traffic flow is going to then be, initially you go here, VLAN 6, this would own the SVI, traffic would flow back down to VLAN 5, we start changing the actual servers on this. And so now the traffic flows, let's say VLAN 5 wants to talk to VLAN 6. It's going to go up here. It's going to have to go to the firewall. It's going to go to VLAN 6, come to VLAN 106. That gets bridged throughout, or bridged, goes back to the firewall, or goes back to the port, and then comes down. So you're able to basically force traffic through it using that layer 2 bridge. And so in this method, it's going to work very much the same way as layer 3, but we're not actually changing the SVI, so you can cut over. We're not interrupting that. You do have to start worrying about spanning tree, because now we're messing around with VLANs, so spanning tree does become an issue. And the other thing is you can start cutting over servers one at a time, because you're actually changing the VLAN tags on the servers. You don't have to cut over entire VLANs at once. So if you've got like a backup server that's a massive throughput, and that's one of the things you're trying to keep off the firewall, then you don't have to look at that. And it also stretches out your implementation cycle so you can implement things as needed. So the pros of this, well, it's doing a VLAN rewrite. The pros of this are it's easy to roll back. That's a good pro. So if something happens in your testing, you can actually just switch that VLAN tag back, it'll roll back. Traffic's now bypassing the firewall. That also means it's really easy to make mistakes to bypass the firewall. So if you've got server teams or network teams who are changing ports and changing VLANs, it's likely or possible that there could be a mistake unless there's a good change control process in place and they actually know what's going on. One of the cons that I don't like about this is it can create spanning tree issues, but also your policies become much more complex because you're now doubling the number of VLANs you have everywhere. You have to have a lot more of those VLANs. Your policies basically double based on that. And it also is a different concept for the way traffic typically flows inside of a network. So we're not used to, as network people, thinking that I need to worry about a layer 2 VLAN pushing traffic through. So if something does happen from the troubleshooting side, your network people have to know that's what's going on, which doesn't always happen. And here's how this would work. So traditionally, you've got your data center switch, traffic goes through, it's all on one VLAN. We build it out and add VLAN 111, and so we're actually going to change that VLAN port. We now have a bridge from 100 to a 111, and so traffic gets pushed through that bridge. And so this is another place where this is actually a good scenario, is if you have an existing infrastructure where you can't mess with the routing protocols, this is a good solution to be able to do that. And so you can push policies there at the zones. And so finally we have Bwire. So what Bwire is we're essentially sitting as a bump on the wire. So you're able to have traffic and push traffic and policies in this mode. So what this means now is any traffic that is coming up, all traffic is going to pass through the firewall here. So anything that's going from this server up to the core and coming back down is going to pass through the firewall. This is basically the least impactful from a networking side of the kind of traffic that you've got. What it means is you do have more top-of-rack switches, is that it requires more physical interfaces. So this can, depending on how many top-of-rack switches, this can actually make the purchase price of your hardware have to go up because you have to support more interfaces to be able to do this, depending on what you're doing. So kind of what the standpoint, let me go back and cover one more thing on this. So one of the downfalls of this is as you have that traffic flow, you see we only have inspection coming from servers here going down to here. If you've got edge servers that are hanging off your 7Ks, so you're also using the 7K as a place where a lot of servers, workloads sit there, we don't have any inspection in those server workloads because the traffic that's hanging directly off there is just going to communicate straight with the 7Ks as long as they're not passing down to these server VLANs. So I know there's some places that are using the 7Ks for both those scenarios, and this doesn't work well in those scenarios. Was there a question? So this is probably the easiest to implement, is one of the pros, because it has the least impact to the networking team of any of these solutions. It gives you good visibility on any traffic that we're flowing through, but it again drives the point of you need to know where your traffic is and where that traffic is flowing to make good decisions on what is going to be the best way to go as far as where you're trying to segment. I think that's So as you look at how the traffic would work here, you see here we traditionally just have like two great big giant zones. You can have aggregate interfaces here. You can break these zones out into various different VLANs, so you can do like some segmentation of the various different VLANs here. Most of the time when people implement this, they just want to say, here's my server zone and here's my core zone, because they're going to look at traffic the same, because it's going up and down. They don't have to worry about segmenting individual zones from a policy standpoint. So traffic could go up one, go back down, so we're inspecting traffic as it's going across the firewall, and you can put protection in place at all those points during that core. Questions on the physical side? No? All right, so as we look at the virtual side, then, we'll go with ESXi or vCenter. So the way we typically do ESXi or vCenter is you have to deploy a firewall as part of that, or as one of the guests inside that host. So the white box here is your server host. You've got this, the firewall is now a guest inside that host. So I want you guys to take a guess based on the way the traffic works and how you have to deploy it here. If you've got a port group here that's a VLAN of traffic and a port group here that's a VLAN of traffic, what would you guys have to do to be able to secure the traffic going through a vCenter host like this? See, what'd you say?
I'm poor, so I'm going to use a Linux box and use IP.
Okay. Okay. So the IP tables, you can use IP tables and now very much function the way you've got the vShield here. So this is VMware's solution to sell you IP tables, is vShield. You're still limited then by looking at what IP tables can do. So it's looking at your layer 4 traffic, which is one of the reasons we're trying to stop just looking at layer 4 traffic, because there's all those things that we covered at the beginning to solve that. Yeah, there's all the other layers. So, but you're right, if that's all you can afford, because you're doing this yourself and you've got your own server at home, it's a good start, because this does cost money. No matter what vendor it is, it costs money. So the way you would do this, though, even if you can use IP tables or whatever, the way you do this is, since it's working by VLANs, you essentially have to set up this as that gateway for the VLAN. So it's now, traffic has to basically pivot up into the firewall to be analyzed by it before it goes out another distributed port or another VLAN. So you're essentially changing the default gateways on those VLANs to be able to move traffic up to that virtual firewall. Very much similar to the way you would do a physical firewall there. And so that's the way it's going to work on like KVM solutions or OpenStack. Let's say you want to go crazy with OpenStack. That's the same way you're going to have to work on OpenStack, which is free but has no support. So it functions the same way to do that, or Hyper-V it would function the same way to do that. And there's a more complex, I've got multiple different servers, and how do I actually protect multiple different servers going through these uplinks and going through these different VLANs and support groups. And so that's kind of an illustration of how you can scale that out horizontally to be able to handle the throughput needs of that. When we start talking about micro-segmentation, this is the big buzzword that everyone wants is, okay, now we can start micro-segmenting traffic. We can still keep those massive VLAN links that everyone has from years and years and years ago that are hard to get away from because, you know, we've all got stuff running out there and changing IP addresses is bad. So this is VMware's solution to do that, is to implement NSX, which is not cheap in any way, shape, or form. However, what it does is it actually adds what we call a service layer here. So you see the firewall itself is now no longer sitting up here as a guest. It is actually sitting in the service layer that NSX adds. And so what you have is there's now this redirect filter here. So we can take the various different applications. So in this case, we're going to take and write web apps. And I'll get to the tags in a second of how we classify what is what and some of the ways to automate that. But if you take these web apps, that web app traffic now has to hit the redirect filter. The redirect filter is going to say, hey, redirect that actual flow to the firewall so the firewall can do all the inspection on it. So we can say something like, the web app is only allowed to talk via a SharePoint application to the SharePoint server, and then the SharePoint server is only allowed to talk with Microsoft SQL to the DB server. So you're really fine-tuning what you have available and what that exposed risk level is. And once NSX looks at that, NSX is actually going to hand the traffic back, and then it can go down to the virtual switch. So all traffic is inspected before it hits the virtual switch, which is one of the key reasons why this is really about microsegmentation, because now I can microsegment every one of my servers before the traffic even goes to another server inside that same host, because it's not hitting the vSwitch before it gets inspected. You see that's got this NSX distributed firewall. This is the same kind of layer 4 firewalling capabilities that you've got. So if you wanted, you could just take, let's say, a database, and the slide did not load up. You could just take, let's say I don't want to inspect database traffic, just allow database traffic to come down and use NSX's loaded server instead of inspecting it here. If you've got backups, things like that you can do where you don't have to funnel all that traffic through the firewall for that higher level of inspection if you don't want to. As we look at one of the other differences this makes for us from a security perspective, we look at dynamic groups. And so I know this is us. I don't know how many other vendors do this, but from a dynamic perspective, we've got all of this information inside of VMware. So we know inside of VMware what the names of stuff is, what the IP address are, what kind of guest OS things there are, containers. So we're keeping all this information in what VMware calls tags. And so you can actually use those tags to build out automated policies in what we call address groups. So these address groups are essentially empty buckets until VMware tells us, hey, there is a SharePoint server out here that matches the SharePoint tag, and these are the different servers that we got. So as you have environments where you're either spinning servers up or even could be deprovisioning servers, you can then take that information and build that into, well, you use a security policy there, I think, yeah. So we're going to delete this firewall, or we're going to delete this server. The process that most of us take when we delete a server or deprovision a server is the server team does it, and the network team and the security team never get notified that it's gone. And so then the policies stay out there, and now you've got big holes, because then a new server gets provisioned, it has the same IP address, there's now a hole for whatever was on the previous server that was there, and the security team never knew that that actually had been re-provisioned, and so there was just a new request for a new permission to come on the server, and so now we've got holes, and you come back 5 years later and you're like, I've got all these rules that never get hit, and I don't have any idea what's going on. That's kind of what we typically see. Never happens for anybody. So, as we do that, what happens is we now see, okay, we're going to actually eliminate that server from, that doesn't match, it should be the one above it. We're going to eliminate that server from what we've got, and then we're going to remove it from this group. So it's no longer in the security policy, it automatically gets ripped out. So that's, once you can start looking at those tags, and being able to use those tags to both provision and deprovision, it A, cuts down on your change control that you have to do, because the server guys should be knowing what they're deploying. And if they deploy it wrong and stuff doesn't work and it's their fault, and it's not the security team's fault, but they have to go back to the security team and say, hey, you screwed something up. And B, when the server guys rip it down and they forget to file that change control process that they're supposed to be filing, then it automatically goes away. So it makes life a whole lot better to be able to track through that. So these are a couple of the other tags that you have, and this works both in, these tags are a part of both things like VMware and AWS. So as you're deploying stuff in the cloud, AWS has a lot of tags that you can do to automate stuff out there, because that's one of the reasons for having a cloud system. Questions on VMware and NSX? And you can interrupt me as I'm going through this as well. So as we look at ACI and what ACI does, ACI kind of takes that and flips it on its head. So what we have now with ACI is we're actually creating what's called a service graph from the applications that are sitting up here on the VM. And ACI says, okay, this service graph needs to go down through, and it moves through the network like this, and then this is where it needs to end up. So that's kind of the templates that you're building in ACI. So as you're doing that, how do you inject security into that process? And what you end up having to do is there's various different nodes that sit here in the spine leaf architecture, the spine leaf fabric. And so through the ACI, you basically have what's called an APIC, and you have that APIC that's part of that service group. And so you can then basically funnel traffic up through, using that APIC, up through that service group to be able to segment traffic. Some of the things that you're doing as you're doing this though, is you notice it's only layer 3 information. Because of the way ACI does stuff, it doesn't have any meta information about what that server is. It's still classifying everything based on your IPs, your ports, your protocols. So it's all layer 4 based information. So as you're actually using ACI and they're building policies and they build these service graphs, it's all based on that layer 4 information, which is what you're limited to doing. So layer 4 information means you're again stuck at the VLAN. So I know Cisco will sometimes say, yeah, we can do microsegmentation. If they're selling you something and they're saying they can do that, dig into the details of what that actually means. Because microsegmentation in their sense isn't what we typically think of as microsegmentation where you're going to the actual server itself. It's microsegmentation from a VLAN perspective. And so you can put firewalls here. You see I have us. This is obviously Cisco, so Cisco better work with this since it's their stuff. But you basically exit, use a VTEP to exit that node. That'll go to the firewall. You'll analyze it, go back in, finish your VXLAN, and go over. So as you look at the differences between the two, what I'm seeing more and more, and talking with some of my reseller friends who do this, they say that this is if you want to microsegment stuff, and you basically want to limit the number of hops that you've got between servers, because NSX, one of the other things it can do is it can do dynamic routing, so you don't have to go all the way out to, let's say if you're using a spine leaf architecture, you'd have to go 6 or 8 hops up and down to be able to get one workload from one place to another. So with NSX, it's actually reducing that, so you can do it in 2 hops or so. So that's one of the benefits. The tagging is the benefit. The benefit of Cisco is port distribution, at least from the way I see it. It's really now a really good way to be able to push out ports and configure ports automatically is what ACI excels at. So you don't have any of the ability to create these dynamic address groups because everything's just an IP address, because that's the way Cisco hands that information off. There's more differences that's a further breakdown. So microsegmentation, yes, NSX supports it. No, it's only supported at the VLAN, which is what a physical hardware firewall is. That potentially one of the benefits that Cisco will give for the ACI model though, is you only need one big firewall. If you've got a whole bunch of hosts inside the VMware NSX model, you basically have to horizontally scale it out, push firewalls on all those different hosts. Whereas using the ACI model, you can have one big firewall. So in that sense, let's say you've got 1,000 different hosts that you're deploying it on, that could get rather expensive for NSX. In fact, that could get extremely expensive for NSX. Depending on the throughput needs that you have, you could buy a single firewall or an HA pair of firewalls, use ACI and be able to push the same type of information through ACI as long as you understand the differences. So it again goes back to what are the goals that you're trying to accomplish and the best way to accomplish those goals. And SIS does not need a terminate tunnel. It uses orchestration, so there's a lot more orchestration that we can do with NSX, where the way that ACI works is it's relying on orchestration from the UCS director to be able to orchestrate stuff and move stuff around, which is a little less full-featured and a little more cumbersome from a management perspective. Imagine that, Cisco management, not necessarily the best. But it works. I guess that's the last slide on that.
But before you go forward, is there a model using Palo Alto stuff using the Cisco Nexus virtual switches as opposed to NSI or NSX?
Yeah, so it's going to work in the same, like that spine leaf, or are you talking about like a spine leaf architecture?
Yeah, but using the Nexus 1000V as opposed to the NSX or the VMware virtual switches.
So it'll work from the standpoint of the Nexus 1000Vs go on top of like ESX, right?
Yeah.
That's the so from what I understand, it functions as the V switch in those cases. So that would work the same way like the ESXi model did. From the standpoint of you basically have to use the guest and funnel traffic through the vSwitch.
Okay, so there's no provision specifically leveraging any of the capabilities of the Nexus project?
To my knowledge, no, but I am not an expert on that. So I will admit that I don't know everything about all Cisco. So, other questions? So from an AWS standpoint then, I don't know how many of you are familiar with AWS or how many people are looking at AWS. I see at least a few hands, so it's worth covering. So from the standpoint of what AWS is AWS by default gives you security group. It's again, that's your layer 4 firewall that's built into AWS. It also gives you ACLs, so you can do network ACLs on it. Again, layer 4. Security groups are stateful, these are stateless, so you have to explicitly create traffic. But that's all you've got, which is not good enough because as soon as you spin any server up in AWS, it's going to be slammed and pinged and scanned and hit by everything that you can possibly imagine as soon as you spin it up. So as you look at kind of the deployment scenarios and how AWS can work, we've got you can put a firewall here in front of that. And so a couple of things that you can do is you have, think of this as your enterprise network. You can create tunnels to it, or if you've got people coming from the outside, they can hit it, they can access workloads here. So functioning as a gateway is one of the modes. Functioning to secure those EC2 instances is another mode. You can basically create tunnels between them. So if you've got various different VPCs, which are, think of VPCs as like tenants, where you're going to put workloads that are distinct workloads. You can do that, or if you've got various different of the areas that you've got inside of AWS, so you can distribute out resources, so if one data center fails, you're not completely blocked off, you can still create those tunnels between there. So to look how it actually breaks down in some of these examples, if we've got the internet traffic, we've got traffic from the internet coming in, and it doesn't show up on this slide. These are technically two separate subnets here. So traffic will come in, hit that core router that you've got, or that core security group. That core security group says, send the traffic to the firewall, so the firewall can actually analyze it for threats, to analyze it for applications, things like that. So you're able to put that higher level of security into the firewall, and then the firewall can then pass it on into your WordPress server that is always known for having all kinds of critical vulnerabilities on it that never gets updated because marketing is supposed to do that, and yeah, they never do, or marketing's contract a company who never does it. So this adds some protection to that. It extends the lifespan of that, so you can actually protect that traffic. As you look at one of the other scenarios, it's going to be a hybrid cloud scenario. So here we've got workloads back at corporate, and as we spin up QA or dev environments or things like that, we want to be able to spin them up and test them in AWS, and so we can spin them back down. So we don't have to spend all that money for all that hardware as we're spinning stuff up. We can pay the on-demand cost to be able to do that. So what you're going to do here is you're going to create that IPsec tunnel back to the firewall that's actually going to be able to ensure the good IPsec information, be able to inspect the traffic as it's going through, to make sure somebody doesn't get compromised here, and now they're injecting stuff and moving laterally, injecting stuff into your dev environment, so like they don't put a backdoor in the code that then causes critical vulnerability that has to be patched on all of your routers. So same way after you get into there is you can now come into the edge, because we've inspected it before we've actually hit this router, or before we've hit the security group, we can then just pass it on to the server subnet, where that QA dev environment's going on. And then from a zero trust segmentation standpoint, so what we have here is we've got multiple different kinds of workloads that we're sharing that are going to be on different VLANs, because it's really easy to spin up different VLANs inside of AWS. That's one of the things they're great at. And so you just need to create all these different interfaces and security zones on the firewall. So as you're coming in, you make this the gateway for all of these different zones, and traffic needs to come back up and down through the firewall inside of AWS to reach that. So you can really do a segmentation standpoint from that the way you would do kind of in the NSX type of mentality, where you just create the workloads that you've got and have those workloads each individually distinct VLANs. that is, yeah, that's pretty much the end. I'll slide, fill it out again. That's the end. So, other questions? Thoughts? Was I completely off base on anything? Yeah.
So, for using the video, what does that actually look like practically for the firewall? I mean, you're not going to buy a physical box and say, "Hey, Amazon, take care of it."
Yeah.
Right? How does that work? How do you spin up an instance to be able to host the firewall?
Yeah. So what you would do is you go into your VPC, and then from your VPC you can go into the marketplace. And in the marketplace, most of the vendors are going to have already pre-built things that you can deploy from the marketplace. So I know specifically we have a couple different models that we can do. We can do basically pay as you go, where you'll spin it up. And if you're trying to test it, you just want to see what it's like. Last time I knew it was like 93 cents an hour is what you're paying to be able to spin it up. Don't quote me on that price because prices change, but if you do like a pay-as-you-go model, that's kind of the way you go. You're at that point essentially leasing stuff from Amazon, so it gets expensive to lease stuff if you're going to do it long term. So if you're actually deploying something out there, then it's going to stay. Then it makes more sense to actually buy a license. You can use that license and move it there, and that license is then transferable. So let's say you want to actually move it to, people are like putting licenses like that on remote sites of equipment where they have like an AD server. I mean, there's all kinds of things that you can do with it, but that is one of the ways that you can do it. Other questions?
I got another one.
Yeah, go for it.
So, leasing, understand, buying license, where's that threshold kind of at? Are we talking about like hundreds of thousands of dollars? Or are we talking hundreds of dollars?
So the threshold of buying a license versus paying as you go, I think is around 8 months. So if you keep a server up and running for 8 months, it is going to be cheaper to buy a license up front rather than pay that cost. And so it gets even, like the further you keep it out, the better it even gets. All right, well thank you. Hopefully it was useful.
So we'll take about a 7-minute break and 7 minutes. We'll take a 7-minute break and we'll get started back up about 15 minutes till. Thank you. Good. Yeah, I know. A lot of actually, my thing, like that team.